Okay, we're going to continue on with three-dimensional geometry, and all we're going to focus on in this video is finding the volumes for pyramid, cones, and spheres. So I want to point you to the description of a pyramid. A pyramid is a solid with a polygon for a base and triangles for faces. This is different than the prism, because the prism had rectangles for bases. The other thing is that there's only one base and then triangles for the sides. So if you look at each of these, I've got some drawings here of a triangular based, a square based, pentagonal based, hexagonal based, and so forth. We're going to be focusing mainly on square based or rectangular based prisms, or pyramids, I should say. So when you're drawing these, if you kind of think of it, if you're drawing a triangular one, if you just draw your vertex and come straight down, draw your line straight down, and then up to your other two sides, it's just kind of an easy way to draw the pyramid. If you're drawing a square or a rectangular base, you kind of draw your triangle flat so that you can see that, and then draw another side off to the edge there. It's not that I want you to really be, become an artist or anything. It's just that I think when you draw it makes you a little more aware of the features, that you only have one base, and at the other end you have this vertex. Okay, so the pyramids again are named for the shape of the base. Each of these are a little bit different. Okay, so again, in this video, all we're going to focus on is just finding the volumes, but I want you to recognize a similarity between the formulas for the volumes. I guess I need to talk about a cone is here as well. A cone is very much like a pyramid. In other words, it has a vertex at one end, but it has a circle for a base. So when you're drawing that one, you would draw, the rectangular looking, or I'm sorry, the triangular face. But if you just draw a slight curve at the bottom, you can see that you can draw, you're implying that it's a cone. I can make them narrow or wide, whatever I need. If you want, you can kind of dot the back end of it. Draw your radius of your circle if you want to do that. But basically I want you to see that it's very much like a pyramid because it comes to a vertex at one end and the other end you have a base. Just in a cone, your base is going to be a circle. So they have that similarity in their shape. It kind of makes sense that they're going to have similarity in their volume formula. You have to find the area of the base, and if it's a rectangular shaped base, that's what you're going to use. If it's a circular base here, like it is for this cone, you're going to use the area for a circle, but then you're going to multiply by the height and then divide by 3. I know the formula here says 1/3 times the base area times the height. I would encourage you just to do your division at the end, and you're going to see how that's going to make things move a little more smoothly if you think of it that way. So in this one, we're going to start out with the volume of a pyramid. The formula is 1/3 the area of the rectangle times the rectangular base. I should point that out, that it's a rectangular base here, times the height. Well, when I'm looking at this, it's just real easy to see my base here of 6 times 4. So I can say 6 times 4 times the height of this whole thing, and I'm told here that the height is 11. So this is 11 right there, times 11, and then do a final procedure of dividing by 3. Dividing by 3 is equivalent to multiplying by 1/3. That just works out very slick and easy for students because you can just go to your calculator and plug it all in. And you should end up with 88 units cubed. Similarly with a cone, again, you're going with that concept of 1/3 the area of the circular base times the height. Because it's the area, the base is a circle, you're going to be using pi r squared. So in this case, looking at this, I can see that my height is equal to 7, and I know that my radius is equal to 3. So I can plug all that in. I'm going to use 3.14 times the radius squared, which we said was 3 squared, times the height of this whole thing, which is 7. And then the last thing I'm going to do is divide by 3. So again, you have to be aware of PEMDAS, which is please excuse my dear Aunt Sally, or do parentheses exponents first, then multiplication and division and addition, subtraction. We don't have any addition, subtraction, but we have an exponent here. So you're going to have to plug that in first. So that's the first thing you need to do, is go 3 squared, which would be 9, times the 3.14 times the 7, and then divide by 3. and you should end up with 66 units cubed on this one. Okay, so the volume formulas are very similar, very easy to execute. Okay, going to a sphere, we just have two straight up formulas which you just have to basically plug into. So for in total surface area, there's no edges, nothing to worry about. It's just plugging in the formula. So the surface area of a sphere is going to be equal to this 4 pi r squared. So I'm going to plug in 4, 3.14, and then our radius is 7, so 7 squared. And I'm going to have to again start here. I need to do the squaring first, so that'd be 49 times the 4 times the 3.14. We should end up with 616 units squared. When I go to do the volume, I'm going to be using this formula here, and what I would encourage you to do is kind of write your 4/3 like this. So you're writing 4 times 3.14, which is pi, times radius cubed in this one. So that would be 7 cubed. And again, you're going to have to start here. So that has to be done first, the cubing. So multiplying by 4, 3.14 times, I believe that is 343. If you plug that all in, it's equivalent to, and then dividing by 3, it's equivalent to finding the ratio of 4/3 and then carrying out a multiplication. This is going to be more accurate. 4 times 3.14 times 343 divided by 3. So I guess I'll write it all down just the way I said it. And that should give you a final outcome of a volume of 1,436 units cubed. So volume is equal to that. Surface area is equal to that for a sphere.